The problem states the refrigerator has a weight of 180 pounds and rests on the tile floor with a static coefficient of friction of 0.25. If the man pushes horizontally on the refrigerator in the direction shown, determine the smallest magnitude of horizontal force needed to move it. Also, if the man has a weight of 150 pounds, determine the smallest coefficient of friction between his shoes and the floor such that he does not slip. So, let's do the first part of this problem first. So, let's see. If the man pushes horizontally, I'm going to highlight it. So, if the man pushes horizontally of the refrigerator in the direction shown, determine the smallest magnitude. So determine the smallest magnitude of horizontal force needed to move it. So the deal is we can use the information given to us in the problem to solve for this magnitude. So first, let's look at this fridge here. So let's sketch it out as a rigid body. So this is our fridge. We know that this refrigerator has a weight of 180 pounds. So this is the center of mass because it is a rectangular object and it has a center of mass at that location. So that distance, let's name it this distance as 3 feet. It's already given to us. And 1.5 feet given to us here. And our mass, our weight of the refrigerator is 180 pounds. So apart from this, this weight vector, the weight of the refrigerator, we also have the force applied by the man, which we will call P. And there's one more force in this case, and that is the force due to friction. So we can show it like this. It is occurring between the tile and the refrigerator, and we will call this small f. All right, so if we take a quick look at sort of what's happening in the question here, is we're looking at the magnitude of P at the verge of slipping. So before we do that, let's quickly sort of look at the summation of forces in the x direction. We have P minus small f equals 0. Therefore, P equals the force due to friction. Now, let's quickly look at the summation of force in the y direction. In this case, we have the negative 180 plus the normal force, which I did not draw. So I'm going to draw that with a white color to not confuse it or to not clutter the F area. So that will be here. And we'll call this, well, it has a magnitude of 180 pounds. So this will be equivalent to 0, this whole summation. And that means that the value of n equals 180 pounds. Now that we have this, we can use our friction knowledge to determine where it slips, at what load. So we know that the point at which this refrigerator moves is when the friction, the force due to friction, is equivalent to the normal force times the coefficient of static friction. So simply, this means that force due to friction is equivalent to N, which is 180, times the coefficient of static friction, which is 0.25. Therefore, we conclude that the force due to friction is equivalent to 45 pounds. Now, this tells us what P is, because we can simply say P equals F equals 45 pounds. Therefore, P equals 45 pounds. And also, it is important to note that a force that is larger than 45 pounds will, again, move this refrigerator. The reason why we pick this equation is because the question is asking for the minimum amount of force needed to move it. So that is our answer for the first part of the question. Now we can move on to the second part of the question. The second part states, if the man has a weight of 150 pounds, determine the smallest coefficient of friction between his shoes and the floor such that he does not slip. So I'm going to highlight that. All right. Now let's sketch out a quick sort of diagram. Also, for my free body diagram before, I forgot to sort of show the x and y coordinates, and that's kind of important. So that's our y direction, and that's our x direction. So let's sketch out this human very roughly here. Not super good at art, so I'm gonna have to stick with me here. That's our guy, and this is the y-axis, and this is the x-axis. Our vectors applying on this guy are the reaction force coming from the refrigerator. So that's that direction. We already know that magnitude because we calculated it in the previous part of the question. So that is going to be 45 pounds this way. And again, the reason why we pick this value is because the question is asking the smallest coefficient of friction such that during this sort of pushing, he is not slipping. So in addition to this force that he is experiencing, he's also experiencing friction at his feet. Now, in addition to that, he also has a weight. So this dude weighs 150 pounds. I will not be doing summation of force in the y direction because clearly the normal force is opposing this sort of weight that he has. This is sort of approaching the part of the course where we're not going to have to show everything with the summation of force in the y direction. I think in the exam it is probably helpful to show everything, sort of write out summation of force in the y direction is equal to blah, blah, blah. But clearly, I mean, if there are two forces applying, and we know this force, then the normal force is going to be equal and opposite such that he is not accelerating in the vertical direction. If he is accelerating in the vertical direction, something is definitely wrong, because then he's either going up to the sky continuously or being crushed into the ground continuously, and neither of which should really be happening. So again, this is our opposing normal force. And finally, we have the friction force that I forgot to show. So that is going to, let's call it small f again. Different diagram, so we can use the same symbol. So now let's do summation of force in the x direction. So let's show that summation of forces in the x direction is minus 45 plus friction due to force due to friction is equal to 0. Now, again, we are considering the smallest coefficient of friction. Therefore, F can be shown as F equals mu static, which is what we want, times the normal force that the guy experiences. So plugging that in, we can get a nice equation. So minus 45 plus mu s times his n, his normal force, which is 150, equals 0. Solving this, we get mu sub s is 45 over 150, which is equivalent to 0.3. And that is our answer. And again, just to go over it one more time, the question asked the smallest magnitude of P here, and also the smallest magnitude of the coefficient of friction, which we both calculated in these two boxes. We boxed our answers here, and that pretty much concludes the whole question. And have a nice day.